I've got a mock assembly line here. So it's a 2-station setup. I've got shop floor viewer on 2 screens. So we're treating this as station 1, and then station 2, and then I've got Factboard and on up on the top. To take you through some of the devices we've got, like Dave mentioned, we've got Intel NUCs, so just small PCs running shop floor viewer and Factboard. I've got 2 of those. COM port, just serial scanner, a Zebra scanner, hooked up to the COM port of the first station. I've got a wireless Bluetooth tool connected to an Atlas Copco PF6000 and a wired torque tool connected to the PF4000. And then I've also got an Allen Bradley Micro 800 series PLC connected to a couple buttons and switches, and an Ethernet light tower as well on the top. So that is our and-on signal for this assembly line. A couple things you can't see we've got going on. As Dave mentioned, the IoT service running in the background on a PC connected to the same subnet as all of this fun stuff. And then as well, we've got a KEP server, OPC UA server. It doesn't have to be KEP server. They just offer a couple drivers that you can use to bring all your protocols into one place. So we're talking to the Atlas Copco tools with an Atlas Copco open protocol. It doesn't only work with Atlas Copco. It's a universal torque tool communication protocol. And then the PLC connected devices are all OPC UA for this demonstration. So what I'm going to do is I'm going to take the barcode scanner and sign on to my first unit. So scanned a barcode, took me to the process tree. I signed on to my first activity at this station, which every work step in this activity has a device. So the first thing that it did was call this first activity or first work step here, which is using my wireless torque tool, which has got 1 cycle. So I've got 2 different work steps right in a row, which are going to call the torque tool. And that is because as you'll notice as I index through these torques, it'll index my images as well. So you can kind of see on the screen, I've got 2 bolts here, and then 1 is highlighted yellow, indicating that's my first torque. So I'm going to go ahead and do that. The tool tray is also on the right side here, which is tied into the first torque tool. So I need to choose the right socket here. And I'm running down the first bolt. I get a pass, moves right to the next work step, and reflects on my work instructions as well. So kind of hard to see, but what it displays when that happens is the result torque and just a green indication that it's good. So what I'm going to do now is fail a torque, and I get red on my controller, red on the work step with a quick summary as to what happened. So it says torque result low, angle result okay. And it saves that data with this work step. So once I go and pass a torque, it's not going to lose that data. So you know when you're looking back at your data, you've got, okay, I failed the torque 3 times. That's what it took to get there. So also in the resource library, you can configure a certain amount of retries to do for these work steps. So this tool, I'm allowing 2 retries. You can allow infinite retries. You can allow however many you want. What that does is once I fail a second torque, it fails everything on the screen, gives the same indication. Factboard will show red now as I've created a hot issue. And then my light tower also reflects the status of the station. So now the tool's locked out. I can't do anything. With the right privileges, you can go back. I'm going to reset this hot issue. Close out my issue. And I'm going to just restart the torque process. Everything returns back to a normal state. My and-on's green. Factboard's green. I can go ahead and torque my second bolt. So that one finishes, moves on. And now I'm calling my first PLC device, which is kind of a mock tool tray. I have a couple switches here and lights associated with them showing me which switches to flip. So it's easy to visualize sending a job from Assembly Planner. What I'm doing to configure this is essentially the same thing. I'm sending it a number which corresponds to which lights and switches I want flipped for this particular unit. So there's no custom hard-coded values when I call this. The only thing that's hard-coded from the PLC side is which inputs am I using, which outputs am I using, because these are all wired directly to the I/O of the PLC. So I'm going to go ahead and flip these switches. That completes that activity. I get to my second activity, which is just telling me to back out these bolts and use a button on the PLC to confirm that I did that. So I'm going to back out bolts. And then go ahead and hit my confirm. And then since this is the last activity in this operation, I have an auto sign off here. You can't really see from the screen, but there's a timer saying I've got this much time before I'm going to auto sign off and complete that activity. So it returns me back to the process tree in this instance, and I'm ready to sign on my second station. So I'm going to sign on to the same serial number, second station, which is just a single activity, torque activity as well. But this time I'm using this torque tool, so the PF4000 wired tool, and I'm going to just, something to note here too, this one is a batch process, so a little difficult to see, but instead of one box, I've got two boxes showing how many torques I need to complete. So we can call either individual P sets, so if you just want to call the P set, or also the job. So a job could be a collection of 5 P sets and a whole bunch of different numbers of those to complete. So we've got, we're just calling a full batch process here. Maybe you don't want to control the work instructions to index every time you complete a torque. So it's populated all of that. It's going to get 2 torques and then move on to the next one. I'm using the same operator, confirm. It's a shared PLC, same device. So I can go ahead and confirm that I've finished that process. Same activity sign off. And I've built a unit.